All right, let's dive right back in. So we got this going on right here. We got this triangle. A is this point, B is that point, and C is that point. All right, so we're gonna graph the perpendicular bisector for AB. So slope of AB is, again, we're just gonna do a lot of counting, make this easy on ourselves, is down 3, excuse me, brain fart, down 4 over 8. All right, so it's down 4 over 8, also known as negative 1/2. So perpendicular slope to negative 1/2 would be 2. All right, so my new slope is 2. Remember, this upside down T means perpendicular. All right, that's what it means. That upside down T is perpendicular. So I need a slope of 2, but what's the midpoint of AB? The midpoint of AB is, again, let's just count. Well, we were down 4 over 2, 8. I'm gonna go down 2 over 4 and boom, it's right there. That's the midpoint. And I'm gonna call that C just for fun, lowercase c. All right, and that point was 6, negative 2. So from that point right there, I found the midpoint. I found my perpendicular slope. It's just a matter of counting from this point up 2 over 1. And boom, I got a line. And let's make it look pretty. All right. So just to emphasize things, this red line's perpendicular to side AB, and point C is the midpoint. So it's a perpendicular bisector. All right. Now, we're just going to do this a bunch of times. Again, you probably have the skill to do it yourself if you want, or you can stay and just watch this video. It's whatever, up to you. Let's do it for BC. The rise over run is up 1, 2, 3, 4, over 1, 2, 3, 4. So the slope of BC was up 4 over 4, which is equal to 1. And what's perpendicular to 1? Well, if you flip 1, you still have 1. So we just got to change the sign and make it negative 1. So negative 1's the slope I want. But what's the midpoint of AC? Well, again, we went up 4 over 4. So let's just go up 2 over 2. And then boom. That's it right there. That'd be 8, negative 6. So from this midpoint, I'll call this lowercase a, is down 1 over 1, so on and so forth. But I got enough, I can just connect these 2 points and you might be wondering, what is going on? Why are we doing this stuff? Well, it's about to get really cool. And just to be clear, this orange line is perpendicular to BC and it bisects it. I should technically put 2 tick marks. All right. And then this last one, we got AC. We're gonna do all this junk again for AC. All right, the slope of AC is down 8 over 4. So it's down 8 over 4, also known as negative 2. What's perpendicular to negative 2? We'll change the sign. It's going to be positive now. And flipping 2, we get 1/2. So my slope is going to be 1/2. Now, what's the midpoint? Well, I went down 8 over 4. This time, I'm just going to go down 4 over 2. And boom, there it is right there. We'll call that lowercase b. Is at 4, negative 4. So from this midpoint, I'm just going to count slope of up 1 over 2. Let me do it outside the triangle. Down 1, left 2. But nonetheless, it doesn't matter which way I go. But oh my gosh, watch, something spooky is going to... Wow, this is actually kind of weird. Notice that all my perpendicular bisectors intersect at one point. Wow, I am truly spooked out right now. What are the chances they would all intersect right here at the same point? Huh, that's kind of weird. OMG, what happened? All of the perpendicular bisectors intersected at a point inside the triangle. Wow, that's kind of crazy. All 3 points intersect, or all 3 lines intersect at the same point. What are the chances? That's pretty crazy. All right, and this is actually a very powerful picture. And here's a little foreshadowing. We're going to talk about this more in the future, but watch this. Let's see how perfect I can do this. This will amaze you. Wow, look how it touches all 3. A circle centered at that point touches all the vertices. Wow, this is some intense geometry right now. I can feel my heart beating. All right, now this one, again, a lot going on. Let's just focus one thing at a time. A is this point right here, B is that point right there, and C is that point right there. We're going to do the same thing we just did, but for a different triangle. That was an acute triangle. So all 3 perpendicular bisectors intersect for an acute triangle. This right here is an obtuse triangle. Let's see what happens here. All right, graph the perpendicular bisector for AB. So again, there's going to have to zoom in and out, a lot of stuff going on, but we'll deal with it. All right, so this was down 6 over 10. So the slope of AB was down 6 over 10, which goes to negative 3/5. So my perpendicular slope to 3/5 will be 5/3. Change the sign so it's positive now and flip. And then again, I went down 6 over 10. So to find the midpoint, I'm going to go down 3 over 5. Boom, that's the midpoint right there. We'll call that lowercase c. And then, so from C, I'm just going to do a slope of 5/3. So up 5, 1, 2, 3, 4, 5, over 3. And then we'll make a beautiful line that goes through that. All right, and again, that's a perpendicular bisector to AB. Now we're going to do the same thing now, but for BC. All right. BC has a rise of 2 over 8. So the slope of BC was 2 over 8, which reduces to 1 over 4. So perpendicular to 1 over 4 would be negative 4. Change the sign and flip. And then the midpoint, up 1 over 4. Again, just counting, boom, right there. So from that point, we'll call that lowercase a. We're just going to do a slope of negative 4, so down 4 over 1. Down 4 over 1. Make a line that goes through it both. That's not perfect. Let me just do it a little bit better. Okay. And again, that's the perpendicular bisector of that. And then got the perpendicular bisector of AC. So AC, let's count the slope. This time it's going to be down 4 over 18. Wow, that's a big number. Down 4 over 18. Which reduces to negative 2 over 9. Then finding the midpoint of AC, well, I went down 4 over 18, I'm going to go down 2 over 9, and boom, right there, that's the midpoint right there. Call that lowercase b. And I forgot to write, the perpendicular slope to -2/9 is positive 9 over 2. So from this midpoint, I'm just going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 over, oh my gosh. Wow. All these lines intersect at the same point again. Wow. And again, this green line is the perpendicular bisector to AC. So this is some intense geometry going on right now. OMG, what happened? We can do this. Let's be a little bit lazy. All the perpendicular bisectors intersected at a point, and then we just have to delete inside, outside. So for the acute triangle, they all intersected inside the triangle. Now what are the chances for some random obtuse triangle, they all intersected inside of the triangle? And watch this, this is pretty cool. I'll do it in yellow not to make it super dark so we can still see everything. Let's see how good I can do this. Little circle here. Wow. So a circle centered at that point for an obtuse triangle. Notice how all the circle goes through all the vertices. Pretty crazy. All right, and then this right triangle, we'll keep it brief. All right, I'll do not too much explanation on this because we've already gone for a long time. But that's the midpoint of this side. Doing the perpendicular bisector would give me that line. Would be perpendicular. That's the perpendicular bisector. Again, I'm just kind of counting really fast. We're not going to be too specific because we're spending a tremendous amount of time on this. That's the midpoint of this side. Again, perpendicular bisector. And then for this last side, the midpoint is right there. And the perpendicular bisector would actually be that. So for this, all the perpendicular bisectors on a right triangle, they intersect at a single point on the hypotenuse. All right, so I wasn't too in depth about what happened. What I can do is I can just paste all the perpendicular bisectors intersected at a point on the hypotenuse. Of the triangle. All right, so that's crazy. All three perpendicular bisectors always intersect at a single point, and depending on what kind of triangle it was, it could be inside the triangle, outside the triangle, or even on the hypotenuse. And look at all these pretty circles. I really like this stuff because this is like pure geometry right here.